Good morning, everyone. My name is Nellie. I'm a director of product design, and I will be your MC for today. Our first talk this morning is Evan Plotkin, a senior software engineer here at MongoDB. Evan joined MongoDB in June of 2020 as a senior software engineer as part of the Atlas Search team. He's worked on improving Atlas Search indexes replication performance and new facets and counts. Please everyone give Evan a warm welcome for his talk.
Good morning. I'd like to start by talking about a little bit earlier this year when my dryer broke and I went online to search for a replacement. At the time, I didn't really know much about dryers, and so I went online, did a simple search for dryer, and what I got was a long list of options. Some dryers had different shapes and sizes, others required different types of power and gas, and I even found dryers that I could control with my phone if I really wanted to. So what happened here? I had searched for dryers, and my search returned a list of dryers to me, but that wasn't really all that helpful. Really what I needed here was some help in navigating all of the options that were presented to me. How many of you have found yourselves in a similar situation when you've been searching for something online? Looks like a decent number of you. It's a pretty common problem, and thankfully it's one that Atlas Search is built to help solve. As you may know, Atlas Search gives businesses an easy way to build fast, relevant, full-text search on top of their Atlas Search collections. A key word here is relevance. Searches return data to users that is most relevant to their search query. But as we've seen, users don't always know exactly what they're searching for. It's also important for search applications to give users the tools that they need to navigate the results and hone in on exactly what they're looking to find. So, this is where facets come into play. Facets are a new feature in Atlas Search that are used to power sections that are like this that are highlighted in red. Facets give a high-level breakdown of the categories in a user's search results and help them explore the options that are available to them. My name is Evan, and I'm a senior engineer on the Atlas Search team. At the end of this presentation, I hope you have everything that you need to know to get started with implementing facets in your search applications. I'll start by talking a little bit more about what facets are and how they're used to enhance user search experiences. Next, I'll talk a little bit more specifically about Atlas Search facets and how you can get started with implementing them. Finally, we'll take a look at an example search page, and I'll show you how you can implement navigated filtering using our facets. So, what are facets? You may not have heard of the name, but you've almost certainly interacted with sections like these on some web page or another before. This is our example search app. It's on demo down in the expo hall, so you're welcome to go try it a little bit. I've got a little bit of a modified version that I'm using to help show you facets specifically. Over here on the left, we have two facets, a cuisine facet and a borough facet. The cuisine facet shows the most common cuisines present in the search results that we have over on the right. The borough facet shows a breakdown of where each of those restaurants are located. Now, note that both of these facets break the data down into distinct categories. There is another type of facet, however, that's called a range facet. Range facets break data down into ranges of values. These are generally pretty useful for numeric and date fields because users typically aren't all that interested in small differences between values. With a field like price, for example, the user wouldn't be super interested in a breakdown of how many items are $19.99 versus $20. Instead, they want a breakdown of how many items are in a low price range, a medium price range, and a high price range. Now, in addition to giving a breakdown of the data, facets can also be used to support filtering on a web page. Each of our facet categories has a checkbox next to them, and here if I select one of them, in this case Brooklyn, it will be applied to my search results, and you can see on the right that all of the restaurants returned to me are now within Brooklyn. In addition to filtering the search results, selecting the Brooklyn checkbox has also changed the cuisine facet filter results. You can see that the counts in the cuisine facet now only count restaurants that are in Brooklyn. As a user narrows their search down and selects different options, they can easily see through the filtered facets what options are still available within their chosen parameters. There are some tricks that go into making this faceting work the way you want, and I'll talk about those later. So now that we've seen some about what facets are and how they're useful, let's talk about how they work in Atlas Search. We'll start by talking about a typical Atlas Search query. At the top level here, we provide an operator. In this case, we're using the text operator. The operator for a search query determines what documents are returned and how they're scored. In this case, our text operator is searching for the term food in the path name and cuisine. The output to this query will be a set of search documents pictured here on the right. Now, if we want to go and implement a facet query, we can take that same search and nest it under this facet key. At the top level here, instead of specifying an operator, we specified facet to say that we want to run a facet search. Underneath this facet key is an operator document where we've included the same search that we were running before. The search still controls what documents are returned and how they're scored, but in this query it will also control what documents the facet query the facets are computed over. Here, in addition to the operator, we also have a facets document. This facets document contains a set of named facet definitions describing the facets you want to compute over the search results returned by the operator. Here, we've defined our cuisine facet on the path cuisine and our borough facet on the path borough. Now, these results will be returned as part of the metadata result document. The metadata result document is a new concept in Atlas Search, and it's used for returning results like facets that summarize the entire set of data. It's not always visible, and you have to make some changes in your aggregation pipeline to see it, but I'll show you how to do that later. As part of the metadata result document, a count is always included. If facets are specified, we also provide a facet document with your facet results. Here you can see that our facet document has both the cuisine facet and the borough facet, and on the right you can see what these results look like. Each facet has a list of buckets, and these buckets contain the categories and the counts for those corresponding categories. Now let's talk a little bit more about this count value that's present in the metadata document to the left. A count is always provided whether specified or not, but by default, the count is just a lower bound on the number of documents that match your operator. The lower bound count of 1,000 here means that at least 1,000 documents were returned, but there may be many more. If you'd like, the accuracy of this lower bound can be tuned, or an exact count can be requested if necessary. So now that we've talked a little bit about that, let's go over some of the different types of facets that we support. Atlas Search supports different facets depending on the type of data that you're indexing, and specifically, we support string, number, and date facets. For the most part, these are similar, but there are some differences in the ways that string facets behave versus number and date facets. This is a typical string facet definition. We've specified the type as string, and we've given a path to the field cuisine, which is indexed for faceting. I'll talk about how to do that later. The output of this facet definition will be a set of buckets and counts representing the most common values at the path cuisine in your data. By default, the top 10 results will be returned, but this number is configurable up to 1,000. In our example here, we've specified num buckets as 5 to indicate that we only want the top 5 results. Number and date facets work a little bit differently. They both also specify their type as number or date respectively, and they give a path to data indexed for faceting. Instead of outputting the top buckets by count, however, number and date facets require you to specify boundaries that define ranges for which to count your data. These boundaries are specified as an array of consecutive numbers or dates, and each pair of numbers or dates defines a range that we'd like to have in our results. In our price facet here, the ranges defined are 0 to 20, 20 to 50, 50 to 100, and so on. Number and date facets also support a feature called a default bucket. The default bucket will count all documents that don't fall into any of the specified ranges. The value of this option is a string, and that string is the name of the default bucket that you'll have in your facet result. If you look at the date opened facet, I've defined a default bucket called historic that will count the number of documents that don't fall into my specified ranges from 2000 all the way into the future in 2023. This means that it'll count the number of documents from before 2000. Now, I mentioned a second ago that to perform faceting, you need to have fields that are indexed for faceting. It's not enough to index a field as a string, number, or date facet if you'd like to perform faceting on them. You need to index fields specifically as string facet, number facet, or date facet fields. However, these facet field types are only used for supporting faceting. So if you also want to do filtering or searching on some of these fields, you'll need to define them as both. From our search application, we saw that we also supported filtering on the cuisine field, so we'll need to adapt our index definition to index it as both a string and a string facet. We can use a simple array here and provide both types in our definition. So up until now, we've been talking about a metadata result where your facet and count results are reported. But how do you access this result, and how does it fit in with your search results? With Atlas Search, Facets, and Counts, every search now produces metadata alongside the search results. A count will always be included, and facet information will be included if you specified facets in your query. In order to see this metadata result, we need to modify our aggregation pipeline to make it visible. One of the simplest ways to do this is by using the $search meta aggregation stage. This is a new aggregation stage that accepts the exact same syntax as $search, so it can be a drop-in replacement. The difference is that instead of returning search results, $search meta returns a single document that contains the metadata results from your query. This is the best way to get the metadata results if you only need access to metadata and not search results. But as we've seen, that's not a typical use case. Usually to build your search application, you need access to both. To do that, you've got a couple of options, but the key for this lies in the $search meta variable. $search meta is a new global variable that is set whenever you run a search command. It contains the results of the metadata, it contains the metadata results for that command, and can be accessed through MongoDB's expression language and aggregation stages. By using these, we can incorporate the value of $search meta into your results and make it visible. Let's take a look at the most common way users will do this. This query uses $search and a $facet aggregation stage to combine both the search results and the metadata results into a single document. The $facet stage may be a little bit confusing. It's not really the same conceptually as search facets. What it does is it allows us to run multiple pipelines on top of the results of that $search stage. In this case, we have a docs pipeline, which limits the search results to the top 10 results, and we have a meta pipeline that uses the replace with expression to extract the value of $search meta and use that in place of all of your search results. We don't need to see the metadata repeated for every single result, so we limit this here to 1. The output of this query will look something like this. At the top, we have our docs document, which contains our top 10 search results that we had limited our results down to. Below that, we have the meta document, which contains our single metadata document with our count and facet results. One notable downside to using the facet operator is that it combines the results into a single document. There's a limit on the maximum allowable size of a BSON document, so when using $facet, it's always best practice to make sure you limit your results to ensure that they fit within a single document. That's why it was important when we wrote our query that we limited the search results down to 10. Now, if you need access to more than just, you need access to more documents that will fit in a single document, you have a couple of options. One simple option is to just execute 2 queries, one with $search meta and one with $search. The $search meta query will return your metadata result, and you can use that to populate your facets. And your $search query will return your search results that you can show your users. Since the $search facet since your $search query is only being used for search results, you don't need to include the facets. Another option is to use a single query with $project. The query on the right here uses project and incorporates the metadata as a field in each of your search documents. This isn't exactly ideal since you don't really need the metadata duplicated, but it's always possible to remove this in your application code. To summarize your options for accessing your metadata, you can use $search meta with the same syntax as $search to get a single document with your metadata results. If you need both, you can run two queries, one with $search and one with $search meta. You can also use $facet to combine them into a single document, as long as you're willing to respect the BSON size limit. Or you could use project to incorporate the results into each of your search documents. There are a number of other options, but these are some of the most common ones that users use. But really, as long as you can do it using our expression language and aggregation pipeline, you can incorporate search meta however you'd like. So now that we've talked about how Atlas Search facets work, I'll show you how you can implement filtering with facets on a typical search page. To power the search example that we've been looking at so far, we'll have a query that looks something like this. Highlighted in green is where we'll inject the user input, and we'll search for that input in the paths in both the title and description fields of our documents. We also wanted to include two facets, the cuisine and borough facet. So we have a facets document, and we've defined these facets here on the right. The cuisine facet with 9 buckets, and the borough facet with 5. In addition to our query, we'll need an index that indexes these fields for faceting. Because we're searching on the title and description fields, we'll need to index those as strings. And because we're both faceting and performing filtering on cuisine and borough, we'll need to index those as both string facets and strings. So now imagine that a user goes to the website and searches for seafood. We'll run our query and use the results to populate our web page here, and the user can very quickly see what cuisines feature seafood. In addition, looking at the borough facet, they can see that there aren't really that many options for seafood in our sample data set on Staten Island, so they may want to stay away from there for that night. So say the user lives in Brooklyn, and they just really don't feel like going that far that night. They can select the checkbox next to Brooklyn, and our search application will issue a new query that incorporates a filter for Brooklyn in the operator. We can see on the right that the search results will be filtered down to Brooklyn, but let's take a little closer look at how the facet results are filtered. Looking at the cuisine facet, you see that the counts are filtered to now only contain results that are in Brooklyn. Pretty quickly, the user can see that there aren't any options for Italian seafood in this data set in Brooklyn, and so if they were really feeling like Italian that night, they may want to expand their search to different boroughs. Now, the cuisine facet is pretty helpful here, but looking at the borough facet, all of the counts are set to 0 other than Brooklyn. This is because when we applied Brooklyn as a filter on our operator, our facets were computed over the resulting search results, which were all set to be in Brooklyn. But this isn't really all that helpful. Seeing a bunch of zeros doesn't give the user much information, and they may not be 100% set on staying within Brooklyn. Imagine that they select the Chinese food facet, peruse the list of restaurants, and don't find anything that's interesting to them. It would be helpful for them to still see a count of how many Chinese restaurants are available in different boroughs, so they can use that information to help decide if they want to expand their search. To support this, we can issue different queries for the search results and each of the facets. For the search results, we'll want to include a filter for all of the categories selected in our facets. In this case, both Brooklyn and Chinese food. To support our facets, we'll need to issue 2 queries, one for each facet, and we'll want to include the filter for all facets other than the current facet. In our query for the cuisine facet, we have a filter for Brooklyn, but not for seafood. And then in our query for the borough facet, we have a filter for the cuisine, but not for the borough. The final page will end up looking like this. We've got our filtered search results on the right with Chinese restaurants that are within Brooklyn. And on the left, we have both of our facets, both with interesting counts, describing how many results are available. Looking at the cuisine facet, you can see how many restaurants are available of different cuisines, assuming that you give up on your selection of Chinese food. Similarly, with the borough facet, you can see how many restaurants are available in other boroughs if you decide not to eat in Brooklyn that night. So, as we through this talk, we've learned about facets in search and how they're used to enhance user search experiences. We've talked about how Atlas Search facets work and how you can implement them in your deployments. And we've also looked at an example search application and talked about how you can implement navigated filtering to help your users hone in on what they're looking to find. As we wrap up, I hope you can take what you've learned today to implement faceting in your applications and help your users avoid feeling a little bit lost and confused the way I did when I was searching for a dryer online for the first time.
Thank you, Evan.
Thank you.
We have some time now for some audience Q&A. Does anyone have a question for Evan? The man in the front. Hold on 1 second.
How are you ranking your search results?
So Atlas Search uses Lucene to rank all of its search results. Lucene has a bunch of different scoring options. By default, it'll give a score based on essentially how common the terms you're searching are in your different documents. But we also provide a number of tuning parameters that you can include in your query to tune scoring a little bit more if you'd like to boost certain results, or if you know that certain fields are more important than others.
Oh, go right over here.
Hi. Oh, this is pretty awesome, the Facets feature. My question is this: how does Atlas Search will compare with Elasticsearch? With you kind of just said there that there are the options to fine tune and boosting. I think I just missed some of that, and I couldn't do because we're all using Elasticsearch. It's kind of like it's been so far. The answer comes with a huge cost of having to maintain the index. So this is like a game changer. But my real life experience has been that it was just kind of missing some of those more complex fine tuning and things. So I think maybe I just didn't know how to find those.
Yeah, Atlas Search is similar to Elasticsearch in a lot of ways. We're actually both built using Lucene, which is a library that supports searching. Atlas Search is really important for kind of being able to have search on top of your Atlas collections without going to a second solution, without having to move your data around and make sure it's in a different system. And we do support a lot of the same features as Elasticsearch. Some of our boost and scoring features are relatively new, and we're continuously working on adding new features to kind of make sure that you have all of the options that you need to tune your scoring and do exactly what you need with your searches.
Oh, there's a man. There's two people in the back. I'm going to run over to you.
Evan, thank you. Just a quick question about, well, hopefully quick, but dive under the covers a little bit. Tell us about how faceting is a little bit more complex than indexing, or since I figure you could possibly use index, why would faceting, what underneath the hood is making faceting more useful than an index in this regard? I just wanted, if you went over this, I'm sorry, just want to make sure I'm just curious about that.
I think so, yeah, so we support faceting. So faceting in Atlas Search is a new feature. It is, I think what you're getting at is that it's possible to also use stages like group and bucket to generate results that look like facets, or that are essentially the same. And that was how a lot of our customers did support facets using search before. But Atlas Search facets, when you're using them with our language and using our syntax, are going to be much faster than using a $search command followed by $group or $bucket. The way that ends up working when you use the aggregation stages is, Atlas Search will essentially send all of every single search result to MongoDB, which will then use bucket and group to aggregate them. But this isn't really efficient, and it can end up being really slow. And so when you do it in Atlas Search, we aggregate everything locally and then just send the final metadata document to MongoDB. So it's much faster. So the reason that we don't do this automatically, the reason why you need to specify facets, and why we can't just take a group or a bucket stage and automatically generate facets, is that Atlas Search has a little bit of different consistency guarantees than MongoDB. And so if we were to automatically perform bucketing and grouping, we would break some of the consistency expectations.
You mentioned that if you want to search on the same field that you're faceting, you need to index just like a string and a string facet. What impact on the search index does that have? Are you duplicating that field in terms of storing it in the index, or can it use the same storage like one time for both?
So there's some tricks that go into that, but the answer is that for the most part, you will not have an impact on the index definition if you define a field as both. For string facets, I guess the only time when that wouldn't be the case, actually, sorry, I should correct myself. For string facets, indexing as a string facet does require a little bit of extra space in your index definition. Lucene actually has some additional bookkeeping that it does to prepare string fields for faceting. For number and date fields, if you specify a number and a number facet field, we'll reuse the same underlying field unless you specify different options. So both number and number facet have some options that you can configure, and if you specify different options, we'll have an extra field in your index definition that requires some more space.
Does anyone have any other questions? Oh, looks like we have a few. I'm going to run over to you. You're closest. Here you go.
Hello. Sorry, I have a question about full text search. Is it giving very good speed, or because I'm using now 4.4 version, I didn't upgrade to 5, and the speed is not very good, even with good indexes?
Yeah, so we're always focused on performance. At Atlas Search, we're constantly making improvements, and from our current performance tests, we have decent performance, but I'd be really interested to talk with you and hear about your specific case and think about if there's anything we can do to make that faster.
We have time for about 2 more questions, so I'm going to take your question, and then we'll go.
Hey, good stuff for this. I've struggled with elastic indexes for a while, so seeing this is fantastic. But related to that, is anything being done to distribute the data across different indices in Lucene based on the facets? And could you run into something like noisy neighbor problems, right, if you have a facet that's overloaded with data?
So Lucene manages facets kind of similarly to how it, sorry, we finished? Oh. It manages facets similarly to how it manages most fields. And so it's split kind of all of the data into different segments, but that's usually all located on a single machine. But we don't really see any problems with this in terms of performance. Again, because all of this data on disk is split up into many different segments that can be loaded separately. As a note, facets are available right now on non-sharded clusters. With the release of 6.0, they will be available on sharded clusters. And so we support distributed facets in that way in the future.
All right, Evan, this is your last question.
Thanks for the great talk. I was wondering, in terms of performance, is there like a maximum number of facets you can use at once?
We don't have a specific maximum, but as you add more and more facet definitions to your query, it will take a little bit more time. I don't think there should be a huge concern with that. I think for most search applications are using on the order of maybe 10 facets. I think we should be able to support even up to roughly 100 if necessary. But most search applications really aren't looking to have that many facets displayed.
All right, thank you everyone for attending this talk. Please give Evan another round of applause.
Thank you.